All right, welcome back, folks. Before we get started, are there things people would like to know regarding the exercises, recommended problems? Anything people would like to check or ask about? Yes? 101? That's okay? Cool. Okay, so let's have a look at 101 together. Is that in section 1.1 or 1.2? Sweet. Thank you. So just a reminder, I usually write that as section 1.2, question 101. Okay, wow. All right. Find the area enclosed by all of these crazy curves. All right, so we've got x, y is, what do we got? We've got cos t e to the t. We've got y is 1 and x is 0. And then we've got that t goes from 0 to pi by 2. Okay, so we want to find the area bounded by these things. So the first step in this kind of a problem, well, what would you do in this kind of a problem? Suggestions for first steps here. Yes? Yeah, draw the thing. Yeah, let's see what it looks like. Totally. Okay, so we'll draw the region, see what kind of shape we get. Oh, hello? Yeah, great. Can you put them in the thing?
Sure.
So we're going to draw the region. Wait, can we give it up for tech support, by the way? This is just awesome. Thank you. Yes, great. Thank you. Is it turned on?
Yeah, it is. It's just muted here.
Oh, okay, cool.
Check 1, 2, 1, 2.
Yeah, give it up for tech support, ladies and gentlemen.
You're welcome, everyone. It's working.
Okay, so.
Check 1, 2. I just want to make sure it doesn't feed.
Okay.
I'll just make sure we're talking,
Okay.
and then I'll get going.
So, I guess I should say why these are important. So these are important for accessibility reasons. If you're at the back of the room, sometimes it's hard to hear, so we're using the microphone just so that it's a more accessible class.
Clip, right?
Yep.
Oh, sweet. Yeah, it should be good now.
Okay.
Awesome.
Thank you. I always thought it'd be cool to get like the audio from this thing and have it like recorded and sync it up with the video. But that's a project for another semester or something. If you know about video editing, I would love to chat. Okay, so we're drawing the region. We're going to see what this thing looks like. So we've got y equals 1. That's easy to draw in. Then we've got x equals 0. Okay, now we've got this very strange curve, right? The curve cos t e to the t. So we'll sort of plot some points. We'll see what happens. So we'll plug in t is equal to 0. Cos becomes 1. E to the t becomes 1. Okay, now we'll plug in our other bound and see what we get there. Cos becomes 0. What? E becomes e to the pi by 2. Number like 4 or something, I guess. So that will be x is 0, y is e to the pi by 2. So we get some point up here, and our curve goes somewhere between these points. Okay, so we get some kind of shape that looks like this, and the region we care about is this guy here. Notice that I'm not super duper concerned with the shape of this curve, just that it has 2 endpoints on this region. Okay, what's my second step? Yeah, sure, yeah.
Taking the integral of the curve, but then subtract from the area of the spheroid.
Yeah, right. So that was very, very quiet up in the front row. We want to integrate this guy and then subtract off this big rectangle below. Right, this rectangle is not part of the region we want, but if we just integrate this, we'll get this area as well. Okay, so now we'll integrate. So that would give us this whole area. Right, it would give us a large area, and we're going to subtract off this bottom part, the rectangular region. So we integrate from here to here, just the function of height 1, and remove that rectangle. So we plug in when we integrate this guy out, we get a total area of 1. Okay, now we've got this d of a function business going on. We've got d of some function, so we have to do a little bit of work here. All right, we have to take the derivative of the function, multiply it by dt, and we get here. And now this is a very, very, very good place to practice your integration skills. Right? This is kind of a tricky integral that you saw in your first year calculus class. So let's say take 2 minutes and integrate that thing. Get an antiderivative for e to the t negative sine t. Okay, so I see a lot of people are working on this. That's excellent. But there's also some people who are getting stuck. So I want to sort of talk about the place where people usually get stuck with this integral. And maybe that'll free up some people to solve the problem. So we want to integrate e to the t sine t. Right? This is a classic example of a situation where we have parts. We've got two functions. So we're going to do integration by parts once. Right, so we'll pick our parts. Right, and we wind up getting the following thing. This is negative e to the t cos t. Then we put in plus integral wait, we've already done something wrong. What's the thing we've done wrong?
Lie should be other way around.
Yeah, so what do we want? We want uv minus v du. Is that the usual formula? Cool. So we'll, oh, right, this is our thing. Much better way. Okay, so we get e to the t sine t plus integral e to the t cos t. Is that better? Okay. Yep.
Isn't this supposed to be negative sign?
Plus or minus, it's all the same. Yeah. If we can do it without the minus, we can do it with the minus.
Professor, shouldn't be using e not UGV. So it should be e negative cosine t.
Negative cosine, right, negative cosine?
Yeah,
Right.
for the e. Oh no, the first part. UV. So like, yeah, for this part should be
Yes, 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 good. So better? Yes. Great, so now we've got another one of these issues to work on, this guy here. Right? So a couple of people said, does this lead us to an infinite loop? Right, where now we've got, one integral e to the t sine t, now we've got another integral e to the t cos t. Ooh. So it's like it could be some kind of terrible infinite loop. Okay, so let's handle this guy. Okay, so now we do parts again. Okay, so u will be e to the t. The u is e to the t.